Today we're going to talk about how do you compare alternatives. And so when you think about a strategy, you have a number of variables that drive that strategy. And those variables are called attributes. And so how do you model it to figure out what an optimal mix is? And so these are the topics we're going to talk about today, about how these problems work. And an example of a really complex system would be like a communication system for an Army tactical system. And that's that you have everything from satellites to boots on the ground. And so you have so many layers. How do you figure out how they all work? And so the first thing to consider is what variables objectives am I interested in? And so these are my key performance indicators like network reliability or mobile throughput. These are and here are examples of attributes regarding quality. So if I say I'm interested in quality, what do I mean? Security, usability, survivability. When I was doing RAMC reports, which is reliability, access, manufacturing, and cost, which the military requires for every device, one thing that was always weird about that acronym was access. But they want to know how many times can you access this? Like, for example, if you're firing a weapon and then you can only fire it so long and then it's going to cool down, well, that says something about the access time. And so what we want to do is figure out, when we rank things, how do we figure out what's the best to what's the worst? And so in terms of analysis, it comes down to what if, looking at different options, and we rank it and then we choose the better ones. This actually goes in line with why I created a course, Data-Driven Decision Making, because it's a mentality that when you make decisions, you don't have to guess, that there are techniques where you can figure it out. And so what happens is these problems fall into what's called an attribute function, and that's you have utility, which is defined by the utility function. You have the variables that drive that utility, and then once you solve them, it tells you what your options are. So an example is, and he took one for a car, it's cost, features, and options. And so when you start subdividing it into like cost, well, what determines cost? It's price, maintenance fees, all of that goes into a cost of ownership. Also delivery, how much energy there's a cost associated with a car from gasoline. How much does it cost me to actually run the darn thing? Anyway, and so he also goes through the other options. No pun intended, options for the car. And so when you model this all out, the things you consider in each of these variables, and the important concept is actually orthogonality. You want to pick variables that are independent of each other. The reason why is when you pick variables that have overlap, then you have a cross-dependence term. So when you say I'm going to raise it 5 units, then you can't isolate it just to raising that 5 units. You also have to look at what all the cross terms are. And then guess what? That cross term is tied to another cross term, and then it just becomes your number of variables actually starts going up as a power law. And so here's an example of orthogonality, price and brand. Well, good brand affects price, and low brand also affects price. So that's what I mean by the need to be independent. Excuse me. I skipped over one slide I probably shouldn't have, and that's that there are two strategies to go about this. Again, it's top-down, bottoms-up, or mixed. And top-down being that you look at the overall problem and then see how it breaks up. Or you start with the characteristics and put it together and see how they're connected. And there's also a mixed approach. There are basic attributes. Those that form the leaves of the trees, and aggregate attributes, the things that come together. And so here's an example. If I go bottoms up, I'm thinking about price, maintenance, number of passengers, everything else, and then I can classify that. into different categories. So in terms of aggregate attributes, they become total cost. Or I could do it top down. I'm looking at a car, what drives the car, the costs, the features and options, that's what I'm interested in. And then those details come out. Execution in an organization, typically you want to be bottoms up. I tend to be a top-down thinker because I tend to think in terms of concepts. Once I understand the concept of something, the details are easy to figure out. Like, for example, if we talk about what are the basic features of a car, well, you know that. The harder thing to figure out is what do I want to look at for my car? And that's the cost, features, and options. And then we have sub-attributes, meaning everything is dependent on something else. So if I say powertrain, that's the engine, transmission, and air conditioning. I could keep going. Engine parts, carburetor, fuel injectors, so on and so forth. You have to decide at what point am I not interested in the utility, my utility getting that granular. And so in order to form, to actually use this in some kind of system, I need to give variables. And so some of those variables could actually be quantitative, but the one I'm measuring it against is called the utility function. That's the value I'm interested in. And so if I put two attributes together, and then I can see how it affects another. And so how do I do this? I make up my own rule. It's utility. It's arbitrary of how you look at it. And so here's consideration for 3 models of cars, of how they rank with all of these. And there's actually a program called DEXI, multiple attribute decision making, and you can actually plug this in and actually run it. So I would recommend you just sit down and play with it. But right now, the thing is, it'll give you these qualitative outcomes that you talked about, and also plotted on grids, also tell you what the sensitivity looks like. And so this is where you need Excel. And that's that. What if I have quantitative analysis that I want to do? DEXI is good for qualitative, but what about quantitative analysis? And so now my utility function is the volume times the price. So let me give you an example of this.